Have you ever looked up at a massive airplane cutting through the clouds and wondered how on earth does that thing stay up there? It shouldn't make sense, right? A plane weighs hundreds of thousands of kilograms and yet it floats through the sky like it's weightless. What if I told you the key to flight lies in something we can't even see, the air itself? Today, we're taking a closer look at one of the most amazing feats of engineering, aerodynamics. By the end of this video, you'll understand what keeps these huge machines flying in the air. Let's start with the star of the show, lift. Lift is the upward force that makes flying possible, and it all has to do with the shape of the airplane's wings. Airplane wings aren't just flat boards. They're carefully designed in an aerodynamic shape known as an airfoil. An airfoil has a curved top and a flatter bottom, and this shape plays a critical role in how air moves around the wing. As the airplane moves forward, the air hits the leading edge of the wing and splits. Some flows over the top while some flows underneath. Now here's where it gets interesting. Because the top of the wing is curved, the air traveling over it has to cover a longer distance than the air moving beneath the wing. To travel that extra distance in the same amount of time, the air on top moves faster than the air below. According to Bernoulli's principle, faster moving air has lower pressure, while slower moving air has higher pressure. This pressure difference between the top and bottom of the wing generates an upward force called lift. This is the force that allows the airplane to rise and stay in the sky. But here's the challenge. The plane's weight, thanks to gravity, is constantly trying to pull it back down to Earth. In order to stay in the sky, the airplane's lift must be greater than or equal to its weight. This is why planes need huge wings and lots of speed to generate enough lift to fight gravity and stay up. Now, while lift is essential to keep an airplane in the air, it's not enough on its own. To move through the sky, the airplane also needs a second critical force, thrust. Thrust is the forward force that propels the airplane through the air, and it's primarily generated by the airplane's engines. Whether the airplane is powered by jet engines or propellers, thrust works in a similar way. It pushes the airplane forward, overcoming resistance from the air. Let's start with jet engines, which are the most common on large commercial airplanes. Jet engines work through a process called jet propulsion. Here's how it works. First, the engine takes in air at the front using a fan. This air is compressed and mixed with fuel. The mixture is then ignited inside the combustion chamber, causing a rapid expansion of hot gases. These gases shoot out of the back of the engine at high speed. According to Newton's third law of motion, for every action, there's an equal and opposite reaction. The force of the gases being expelled backward pushes the airplane forward. Think of it like blowing up a balloon and letting it go. As the air rushes out, the balloon is pushed in the opposite direction. For smaller airplanes, propellers generate thrust by rotating at high speeds. As the blades spin, they create a pressure difference, similar to how airplane wings generate lift-pulling air from in front of the propeller and pushing it behind. This backward motion of air creates the forward thrust needed to propel the airplane. However, thrust isn't the only force acting on the airplane. Just as gravity pulls the plane downward, another force, drag, works against the airplane's forward motion. Drag is essentially air resistance, and it increases as the airplane moves faster. It's like when you stick your hand out of a car window while driving. The faster the car goes, the more the wind pushes back against your hand. This pushback is drag. In an airplane, the shape of the aircraft, its speed, and the thickness of the air all contribute to how much drag it experiences. There are two main types of drag, parasite drag and induced drag. Parasite drag comes from the airplane's interaction with the air, caused by friction and turbulence as air moves around the plane's body. The faster the plane goes, the more parasite drag it faces. Induced drag is related to the production of lift. As the airplane's wings generate lift, they also create swirling vortices of air at the wingtips, which produce drag. To keep the airplane moving forward, the engines need to produce enough thrust to overcome drag. If the drag force becomes greater than the thrust, the airplane would slow down. So, for smooth flight, the airplane must balance thrust to counteract drag, just as it balances lift to counteract gravity. The faster the airplane flies, the more thrust is needed to keep it moving. By balancing thrust against drag and lift against gravity, an airplane achieves stable flight, gliding through the skies. So airplanes stay in the sky because of four key forces: lift, gravity, thrust, and drag. It's all a delicate balancing act. And what happens when the airplane needs to land? The pilots reduce the thrust, which lets drag slow the plane down, and they decrease lift by adjusting the angle of the wings. Gravity takes over, and the plane gradually descends. But wait, how do pilots control the airplane's direction and stability? This is where some cool engineering comes in. Airplanes have several moving parts on their wings and tail that help with control. First, you've got the ailerons on the wings. These allow the airplane to roll left or right. Then, there's the elevator on the tail, which controls the nose, pointing it up or down. And finally, the rudder, which helps the plane turn left or right by controlling its yaw, kind of like steering. By adjusting these controls, the pilot can make the airplane climb, descend, turn, or roll, all while balancing lift, thrust, drag, and gravity. Here's an interesting fact. Did you know that in addition to using wings, some advanced military planes like the F-22 Raptor use thrust vectoring? This means the direction of the thrust can be changed, allowing for crazy aerobatic maneuvers. Imagine being able to point your jet's engines in different directions for extreme turns or flips. It's like piloting a flying supercar. So now you know the basics of how airplanes stay in the sky. It's all about the science of aerodynamics and balancing those four forces: lift, gravity, thrust, and drag. Next time you fly, you'll know exactly what's happening as you soar thousands of feet above the ground. Thanks for watching. Make sure to hit that like button, subscribe for more fun and fascinating science explained simply.